Welcome to The Explainer. Today, we're skipping right past those simple, forgetful chatbots you're used to, and we're diving into the fascinating and honestly sometimes a little terrifying architecture of fully autonomous AI agents. We hear the word agent thrown around literally everywhere right now, but what actually separates a standard chat window from a truly independent digital worker? Because let's face it, we all know the pain of a chatbot completely forgetting what you asked it just 5 seconds ago. So we're going to break down exactly how these new systems are built, how they manage to learn and remember, the massive security risks they bring to the table, and how the absolute latest enterprise tech is stepping up to solve those exact problems. We've got a ton of ground to cover today. We'll start with what actually defines an agent in Section 1, then move into how they loop and build memories in Sections 2 and 3. After that, we'll hit the massive security obstacles in Section 4, and finally wrap up with how modern enterprise infrastructure is fixing things in Section 5. Let's get into it.
All right, Section 1, Beyond Simple Chatbots. Let's set the baseline and define exactly what pushes a system from just being a standard large language model into a true agent. So unlike your typical standalone chatbot that acts kind of like an amnesiac assistant, just spitting out a response in milliseconds and then forgetting you exist, true AI agents are basically digital employees. They don't just sit around waiting for your next prompt. Think of it like a coworker who actually has their own desk, a filing cabinet, and a whole set of tools. Based on Microsoft's architectural breakdowns, these systems really rely on 4 defining pillars. You've got planning, which lets them sequence actions toward a specific goal. Then there's tool usage, meaning they can actually go out and execute code or browse the web. There's perception, allowing them to process data from their environment. And crucially, memory. They actually remember past interactions and self-reflect to get better over time.
Moving right along to Section 2, Inside the Execution Loop. Now that we know what these agents are, we really need to look at the engine driving all that autonomy. So the real core of this autonomy is the agent execution loop. Here's how it works. The agent gets an open-ended task, calls the model to pick a tool, executes that tool to grab real-world data, like grabbing a livestock price or doing a web search, and then loops back to reflect on those results until the job is actually done. To really put this into perspective, think about a real-world implementation like the ClawIntel Agent. This is a persistent, autonomous system powered by NVIDIA Nemotron. When it kicks off its execution loop, it actively retrieves tech event data from external sources, analyzes and ranks the relevance of every event, generates a structured report automatically, and then actually stores those results into its long-term memory for future reasoning. It runs continuously, totally in the background without any human intervention at all. If you were watching it run in a terminal right now, you just see it executing autonomously, churning out reports, and saving memories all on its own. It's a perfect showcase of task planning, tool usage, and long-running execution in action.
Now, when developers are actually building these loops, they run into a major architectural choice. On one hand, you have highly controllable orchestrators like LangChain's LangGraph. This setup gives you explicit, precise control over the agent's chain of thought, which is exactly why companies like Uber and LinkedIn use it in production. But on the flip side, you have these highly experimental systems like AutoGPT Classic. AutoGPT just runs continuously with these built-in autonomous loops based entirely on a single goal you give it. It is incredibly autonomous, meaning it can run for days unsupervised. But the trade-off? You lose a lot of control. It's like you tell it the destination, but you have absolutely no say over the crazy path it might take to get there.
And that brings us to Section 3, the need for memory. Because if an execution loop is going to run successfully across multi-day sessions, it absolutely has to remember its past actions.
Seriously, an agent that runs for a week what forgets what it did yesterday is basically useless. So to solve this retrieval bottleneck for long-running agents, systems use these incredibly sophisticated architectures, like the memory bank pipeline. In these setups, memories aren't just dumped into some static database. They're actively, dynamically managed. The system warehouses conversation logs and builds evolving user profiles, and then dynamically pulls them up using dense retrieval models. But honestly, the coolest part is the updating component. These systems actually feature a human-like forgetting mechanism. Think about it. You remember your current Wi-Fi password, right? But you've definitely forgotten your childhood landline number. The agent does the exact same thing. If it recalls a memory and uses it successfully, that memory gets strengthened. If it just sits there unused, it naturally decays. This is exactly where architectures like Mem0 step in. It builds these really meaningful links between different memory nodes based on semantic similarities. So when new information comes rolling in, the LLM continually updates and refines its existing notes on the fly. This stops the agent from just getting swamped by a bunch of disjointed facts, and instead builds this rich contextual web of knowledge. And it's this incredibly intelligent management of its own memory that gives the agent the illusion of having a truly infinite context window. All right, Section 4, the Agent Trust Trilemma. We've got an agent that loops completely autonomously and remembers absolutely everything. Sounds pretty amazing, right? But this leads us to a massive, massive obstacle.
The threat model here is frankly terrifying. We are way past the days of a stateless chatbot where the absolute worst-case scenario is it writing a slightly bad essay. Now we're talking about a persistent system with actual shell access and live credentials. That means every single prompt injection attack suddenly becomes a potential credential leak. Every random third-party tool the agent decides to install, that's an unreviewed binary with file system access. And every subagent it decides to spawn could easily inherit permissions it was never, ever supposed to have. No way you want that running unchecked.
Which brings us to the trust trilemma. This is a massive roadblock for anyone trying to put these digital employees into real-world production environments. In any enterprise setup, you absolutely need three things: safety, capability, and autonomy. But here's the catch. With the approaches we have right now, you can only reliably achieve two of those at the exact same time. It's the ultimate pick-two scenario.
So, how does this actually play out? Well, if you make the agent safe and autonomous, you have to lock it down so hard that it literally lacks the tools and data access to do its job. It's safe, sure, but totally useless. If you make it capable and safe, you end up having to gate every single action behind human approval. Congrats, you just became a highly paid babysitter for a piece of software, which completely defeats the point of having an autonomous agent. And if you make it capable and autonomous, giving it full access to just run wild, well, now you've got a highly dangerous, long-running process that's basically policing itself.
Let's move into our final section, building production-ready agents. How are modern frameworks actually solving this trilemma so we can deploy these agents safely in the real world? To actually get the incredible productivity of autonomous agents without totally giving up control, developers are turning to enterprise structures like the AIQ NVIDIA Blueprint. This basically acts as a super secure architecture for research and reporting agents. What it does is separate the reasoning engine from the data retrieval engine. This safely connects the AI to your enterprise files and web searches, all while keeping these strict, highly observable guardrails around what the agent can and absolutely cannot do. Breaking that stack down a little further, it works by isolating the core components. First, you've got the Nemo Retriever, which is the block that securely hooks into your highly sensitive enterprise data without ever exposing it. Then, the Agent Intelligence Toolkit manages all the execution, evaluation, and optimization. And sitting right in the middle, doing all the heavy cognitive lifting, are specialized reasoning models like Llama Nemotron. These models are what actually equip the agent with the skills to think through incredibly complex problems safely. And powering this safe reasoning is the open-source Nemotron 3 Super. This thing is massive. We're talking 120 billion total parameters, but because it uses this incredibly efficient mixture of experts architecture, it actually only activates 12 billion parameters at any given time. That makes it insanely efficient for the heavy, repetitive demands of agentic reasoning, where the model is getting called over and over and over again in that execution loop we talked about earlier. What's really vital about Nemotron 3 Super is that it was pre-trained on 25 trillion tokens, and during its post-training, they put an intense focus on multi-step, tool-using behavior. It leverages some wild efficiency techniques like latent MoE to hit up to 7.5 times higher inference throughput than comparable models. Basically, it is blazingly fast. But the real game changer for you, because it's open and so highly efficient, you can run the whole thing locally on your own enterprise hardware. You get absolute privacy and safety, which effectively breaks that trust trilemma right down the middle. So, as we've seen throughout this explainer, these systems are rapidly evolving from fun little experimental toys into a secure, highly persistent digital workforce. They have memory, they have tools, and now they finally have the secure infrastructure needed to operate safely out in the real world, which leaves us with a pretty profound question to walk away with today. As these agents start completely taking over the execution loops, will human developers soon act purely as orchestrators of these multi-agent systems, managing the big picture strategy while the agents handle all the hands-on coding? It's a fascinating future, and honestly, it is arriving way faster than we think. Thanks so much for joining me on this explainer, and keep questioning the tech that's shaping our world.